Hello, everyone. Thanks for joining the first Cloud Native Brisbane Meetup session. The Cloud Native Brisbane Meetup group, the aim is to sort of build a community of people who are interested in cloud native technologies, things which primarily come from within the CNCF ambit, but also extended technologies from CNCF. It's also for all of us to learn and hear about some of the amazing cloud native experiences that the worldwide community has been building. We strongly encourage participation and would love for folks to share what they're working on and their thoughts. It's more about learning and understanding from each other and sort of building a community which helps each other in terms of learning cloud native technologies. The first session, James McAfee from VMware, he's an amazing technologist. Uh, he'll be sharing his experiences on building developer platforms on Kubernetes. Uh, James has had a lot of experience on primarily Kubernetes and building dev platforms in Kubernetes. So over to you, James. James,
Thanks, Pradeep. I really appreciate it. Thank you for having me on this very first session. Let me share out my screen. One moment. Okay, hopefully everyone can see the big PowerPoint on the screen. Perfect. Okay, so good morning, everyone. Thank you for taking your time this week to join the very first session of this meetup. And I'm going to, as Pradeep mentioned, talk through my experiences looking and working with Kubernetes and related cloud native technology. So just a little bit of an introduction. I'm based in Sydney, Australia, and I cover application platform architecture at VMware for Asia, Pacific, and Japan. I'm a big proponent of open source. I'm a contributor to Kubernetes. And prior to COVID, I used to run the CNCF meetups in Sydney and helped bring about the first official Kubernetes events in Australia. So this is a topic that's quite near and dear to my heart, and I hope to share those experiences with you today. So this talk is looking at Kubernetes, but from a platform perspective. And so kind of to illustrate what I mean by that, you may, for those who are somewhat familiar or have a working knowledge of Kubernetes, you may have seen tweets or comments in the public space, something about Kubernetes being a platform to build platforms. And so I've been working with Kubernetes for some time, and I remember in the early days hearing that message and wondering, what does that really mean? Platform to build platforms. I'm not really sure because, I use it to run containers. I'm not sure, like, is there something else that I'm missing? And so when we take a look at it, if Kubernetes is supposed to be a platform for building platforms, i.e. like a foundation, then what does the rest of the house look like? And so that's what I'm going to cover in this session today. And so if I put myself in the shoes of a developer and I think about all the services that I need to interact with regarding, whether I'm an enterprise developer working on business architecture, or I'm developing SaaS services or mobile capabilities, these sorts of things, these general concerns are really going to come up. And the more tooling that I have to make these processes and interacting with these capabilities easier, I'm definitely going to be quite interested in. So let's take a look at Kubernetes for a moment with that kind of framework in mind, thinking as a consumer. So you may have seen on YouTube these different videos where someone will go through and explain a complicated topic at different levels of understanding. Like what is a kindergartner's understanding of physics? What is a high schooler's understanding of physics? And what is, a cosmologist's understanding of physics, these sorts of things. And so from a Kubernetes perspective, I try to translate that and distill common experiences, both my own and people that I work with and talk to in the community. And I think, the most fundamental level that a lot of people see Kubernetes is a way to run containers, right? So we have containerized our applications in order to take advantage of a number of things, but now we need to run them somewhere. And because running singletons, as in a single service in the cloud, is probably not a great thing due to the cloud generally favoring commodity hardware and scale-out architecture. We're going to need some way of distributing and running these containers using a scheduler, right? And thus, Kubernetes, we can use that as a hosting environment for containers. So the next level understanding that we generally work through is taking a look at some of the API features of the environment that we can use. And so we start to take a look at the declarative API. So this means that if we tell the API, the Kubernetes API, that we want something to exist in a certain way, it will go and do that. You don't care how, just get it done. The other thing is from an API resource. These resources are immutable. So what this means is every time we change an API resource or object, it gets a different version. The other areas around container image layer immutability and mission webhooks, what I'll get into in a little bit, means that this platform is actually really good for CI/CD, so that we can integrate it with our build systems to automate the provisioning of applications into test environments, staging environments, UAT environments, production environments, et cetera, in a way that's consistent, where historically we haven't been able to do before. The next level understanding is looking at the extensibility of Kubernetes. And this really comes in the form of some interesting things that they have done with the Kubernetes API. It allows us to go through and define our own custom resource definitions, which is basically allowing us to define our own objects in the API model, and then custom controllers, which is some software that we can write in order to interact with those custom resource definitions, as well as the built-in primitives of the Kubernetes API, such as pods and stateful sets, et cetera. And so this last area, I think is quite interesting. And this is what we're going to build the rest of the talk off of, is this extensibility. And, so for instance, we have this extensibility, but now what? And so, in my head, I think about this quote, from someone famous, actually nobody. I use the cloud to create virtual machines. And what this means is that nobody is really looking to accomplish anything just to run virtual machines, right? Usually there's some sort of goal. So to kind of translate things, in the early days of x86 virtualization, a lot of people wanted to do data center consolidation by taking the physical servers and bringing them into virtual machines, or taking advantage of having their servers defined in a software-defined manner and automating the heck out of it, these sorts of things. But there is pretty much some sort of goal to accomplish more than just creating the VMs. And the same it can be said for containers, right? So when we talk about Kubernetes, and we mentioned, Kubernetes is a place to run containers, that's actually kind of looking at it a little bit too closely. We want to think about Kubernetes in terms of like what we're trying to accomplish from a business perspective, and then some things come to light. So let's park that for a moment, and I'm going to kind of run through kind of how we can push the extensibility of Kubernetes. And so what we have here is let's say we're doing a pizza service for our organization, right? And so we want to be able to automate ordering pizzas from, I don't know, whoever, Pizza Hut, Domino's, or anybody who's got an API that we can interact with from a pizza perspective. And so the typical built-ins that I mentioned earlier in Kubernetes, the ones that are listed here on the left-hand side. But if we want to do pizza as a service, we're going to need a pizza primitive so that we can interact with it. And so with Kubernetes, what we can do is use a custom resource definition. And in there, we can create a spec for pizzas. And in that spec, we have the schema, and we can say this pizza is an object and it's got certain properties, such as a crust, a topping, these sorts of things. And so now that the Kubernetes API has a concept of what a pizza is and its properties, we can now write some software to interact with it. So let's take a look at a couple of ways that we can interact with our pizza object. When anybody submits something, let's say using kube control apply or whatever manner that they want to use in order to send a spec to Kubernetes to have it do something, it goes through what you can call a request pipeline. You have the API handlers that do all the normal stuff from a REST perspective, and you send your pizza spec over to it to create a new resource based upon the pizza object. In this case, we're sending a thin crust pizza with topping of cheese. The next bit is the emission chain, and there's a couple of things that can happen here. The first one is a mutating webhook. This means if we send a spec to Kubernetes, it can change the spec to accommodate certain things. So in this case, we sent thin crust pizza to Kubernetes, but the service that we're ordering from doesn't have thin crust. So all pizzas are going to be thick crust, right? So the mutating webhook is going to change this pizza to crust type thick. The next thing is a validating webhook. And so this is where we can do a filtering exercise to say, is something allowed or is it not allowed? And in this case, we have somebody completely off the wall sending a pizza request with a topping of pineapple. So, we're going to do the only sensible thing that can be done in this picture and just refuse that request completely. So we really want some reasonable toppings on that pizza. And finally, if it makes it through that emission chain, we need to now instantiate it and persist it in etcd, which is the state persistence layer for Kubernetes. It's where it stores all its information. So now we have an object of a pizza known to Kubernetes. The next aspect of what we can do from a software perspective is write a pizza controller. So there's no use having an API object that we can't do anything with. And so within Kubernetes, as I mentioned, it's a declarative model. And what this means is that there is a set of processes within Kubernetes that are constantly looking at the environment. And whenever anything happens, you can think about it in your standard CRUD perspective, create, update, delete, etc. Whenever these events happen, there's a reconciliation loop that has an informer interface that watches for this stuff. And so let's say we have somebody submit an object, a pizza object, and it's instantiated within Kubernetes. That's a creation event. And based upon that creation event, you can have some business logic that you write that picks up on that event and does something. So in this case, it goes out to the Domino's API and creates an order. The next thing is maybe somebody wants to change the order and add some, something else, or they want to change the topping or what have you. Or if you had some other objects like the concept of a drink and you want to order a Coke or a Pepsi. By the way, they're not sponsoring this, so you can have these update events and you can write business logic across the update events. And lastly, for delete, let's say, hey, actually, we're just going to go out and get burgers instead, and we don't need this pizza thing. So we can do a remove event. So, kube controlled delete. And you can have some business logic that's looking for these delete events, and then it goes out to the Domino's API to cancel the order. So this is a completely legitimate thing that you can do with Kubernetes, just using the standard extensibility that's there. Now, probably none of you are going to go out and create this pizza service, but you can understand that as you apply it to your business, there's a lot that can be done here, and it doesn't necessarily have to be done with regards to just containers alone. So what I'll do is I'll take a look at some more practical use cases for this extensibility. And what I've listed here is what I would call generalized solutions, meaning that these are technologies that will be defined in this presentation that would look more or less the same out of the box from one organization to another. The reason why I kind of put a caveat around here is that when we're creating platforms for our organizations, the real value add is us creating a platform that's specific to our organization, right? That does something for our organization, that takes out lengthy processes or work that nobody wants to do, but it has to be done, these sorts of things. So the first one that may be easy to think about is Kubernetes as a service. So to kind of go back to the very first, or the second slide where we have understanding of a user, it's going to be very important for these talks about platforms to have that user in mind. And so whenever I think about services or platforms, I think of two groups of people. One is the consumer. This would be the web developer, whoever is accessing your platform. And here are some services that they may invoke on the platform and use and consume. And the second one is the provider. This is whoever is creating the platform. These are the capabilities that they need to instantiate in order to provide those services to the consumer. And the very important thing here is to always have a clear understanding of who is the consumer and who is the provider. This allows you to define a clear interface between the provider and consumer without leaking sort of any of the how the sausage is made items from the provider into the consumer land, which happens a lot. And so I think that it bears in mind to keep this understanding of who is a provider and who is a consumer, and understanding precisely what their interests are. So Kubernetes as a service. Let's do a little overview. So when Kubernetes started to come out, a lot of people would use it to have like a single cluster, right? They had one big cluster for everyone. And as time went on, people realized actually that's not a very good idea. We should probably have more clusters and have a more granular control over the applications, because in Kubernetes land, it doesn't have strong tenancy isolation. It only has soft tenancy isolation. And so the more Kubernetes clusters you have, the more security boundaries you can use and control that you can have, and reduce kind of noisy neighbor syndrome. So if we're going to have a fleet of Kubernetes clusters, we're going to need a way to be able to automate and provide this capability as a service to the consumers. And so operational access is incredibly important. And so considerations around how someone might be able to request a Kubernetes cluster, within Kubernetes, and this is part of the Kubernetes I worked on, a component called Cluster API. We're now able to define a cluster object in Kubernetes and tell it, hey, go ahead and create these other Kubernetes and manage the lifecycle of those other clusters. So basically, Kubernetes can now do for Kubernetes what it had been doing for containers. The other thing that we look at from a Kubernetes as a service perspective is, your standard backup and archive services in order to handle the workloads that are on there. So if something gets removed, we can recover from it. Observability, we need to make sure that we provide the capabilities to understand what's going on in the environment, if not for our own perspective, but I'm sure that whoever's using the environment is going to want a view of that as well. Multi-tenancy, as I mentioned, we have soft tenancy within Kubernetes in the form of namespacing. Namespacing doesn't do tenancy for every object in a cluster, but it does it for most. And we need a way to be able to make it easy for people using the Kubernetes clusters to understand how that tenancy works and how they partition their components into different namespaces. Platform lifecycle, Kubernetes has a strong cadence of releases. It's incredibly important to keep it up to date. You don't want to be running a Kubernetes cluster that is a couple of years old and sort of looking like Swiss cheese from a security perspective. And lastly, going back to understanding, who's a consumer, who's a provider, and being able to have a clear UX that people can interact with and use. So here's a screenshot of one organization's way of providing that UX. And so what you see here is a way to define a namespace. You can put in some different tags so that you can manage it in certain ways. You can understand who are the approvers for such a capability, where you want it to be placed, etc. And so these are quite common. What this UX looks like, I've seen from many organizations to another. But that kind of gives you an example of what one team has created in order to allow access for the users. So if we take a look at from a service stack perspective, from the work that I do, with the customers that I interact with, there are common components that I usually see from like a Kubernetes as a service stack. So for instance, you have a control plane. So this would be where you start to put your common services that handle the entire fleet. So you've obviously got a management capabilities for the clusters. You'll need service catalogs for defining what's available within your platform. You're going to need integration services so that you can tie in with components and services that are running in the organization. And then you're going to need probably some shared services because there's within, let's say if you have multiple application teams and they're all developing applications that are within similar security remits, probably no need to go in and create each one of these in every single tenant zone. You'll probably just leverage these as shared services. So image registries, certificate management, logging, monitoring, archiving, these sorts of things. And finally, here are your tenant services where you instantiate your tenant cluster and have them available. And so this is all kind of the back end for what that UX looks like for the user in terms of the previous screenshot where the requesting namespacing resources. And so a lot of these capabilities are available within Kubernetes by default, as well as within, for instance, the CNCF. You'll see there's tons of tooling available in order to do these. So you don't have to code and develop this stuff from scratch. And I would argue you probably wouldn't want to spend that time to define these things. Just go and get those technologies, integrate them, and focus the time on sort of the business value add. So next sort of generalized platform is database as a service. In this case, I'll take the open source project kubedb. And in a similar manner, and you're going to see a common pattern here, is that there's going to be a few threads that'll be consistent between these different platforms. Again, operational access for create, update, delete methods for being able to provide database services. You'll need to consider integration with externalized services such as data retention, data backup, archive services. Multi-tenancy, you'll need to consider, again, because of that soft tenancy perspective, how that impacts what you're trying to do within the organization, right? You don't want to put sort of applications that are responsible for PCI, credit card information on something that's completely unrelated in different security zones. So that would be a big security no-no. So you want to understand tenancy. Do you need to use namespace within a cluster for tenancy, or do you need to use clusters as the tenancy model? So a cluster for one team and another cluster for another team. Observability is always super important, especially for databases. And consumer access, once again, this is another common theme and thread that you'll see coming through here is the UX. The UX is king for any platform. And what this looks like, to kind of go back to the components that I mentioned earlier around how we can extend Kubernetes, someone can submit a spec. In this case, they want to set up an order database. They want it to be MySQL, and they are going to give it a certain type of characteristics and storage space, in this case 10 gigabytes. We'll send that to the Kubernetes API, via maybe kubectl apply. That request will go through the emission chain. kubedb will have a DB mutator and DB validator that will go through. So if you remember sort of that emission chain that I talked about in the very beginning, and once it goes through there, it's persisted to etcd. Scheduler picks up on that via the reconciliation loop and works with the kubedb controllers that are installed to then instantiate different things. So the kubedb controllers, some of them are listed here. They have controllers for the different types of databases that you may want to instantiate on Kubernetes. So you can see, the common suspects, the usual suspects from a database perspective. And in this case, we request MySQL, so we get MySQL. And in MySQL is composed of the normal Kubernetes primitives, such as the service, stateful set secrets, config map, etc. But you'll notice that the user didn't have to request those individual components. They use the custom resource definition, the custom controllers, so that they can focus on their business value or their business objective, right? They need database for state persistence. They're not, using the cloud to create VMs. They're not using Kubernetes to create containers. So another thing that we can do is go to a snapshot. So if you recall to the previous slide around integration capabilities, what that could look like in this case is sending a spec to Kubernetes. In this case, I want to do a snapshot on the storage here that goes to the Kubernetes API and all the way to using the kube controllers, kubedb controllers in order to make that snapshot available, in this case on external storage. And so, this can be expanded to other databases, as I mentioned, through the DB controllers. And hopefully this kind of gives you an idea from a database perspective of one type of approach that you can utilize. Another type of platform is functions as a service. So there's quite a few functions as a service projects for Kubernetes. In this case, I'll just use Knative as an example. OpenFast is another great one that could be used. Here we go, common threads again, operational access, service resolution, how the services will be defined for your functions. This is incredibly important so that they could be used as a part of a chain or accessed externally. Observability, also super important. How are these functions working? What is the spin up time? How long do they run for? How frequently are they called, etc. Advanced route management. This is also super important from a FAS platform in terms of when we're defining new functions or new versions of functions, how can we route traffic as we change the environment? And I'll get into that in a moment. Language support. So, not everyone wants to code in Go, even though it's the best language. So you need to have the flexibility in order to do that for the different teams who are creating their apps. And consumer access to the UX and auto scaling. There's not much to a FAS platform if the functions can't scale out. You're going to want to be able to do things in parallel for a FAS platform. Right. Okay. So back to our standard API model and controller look. So once again, Kube API. It now has a resource defined, understanding a concept of a service with using the serving API from Knative. And we go through and we define the components for our function. That goes into the Knative mutators and validators. Everything's good. So go to etcd, get it scheduled so it's running on the Kubernetes worker nodes and have the controllers do some sort of thing with it. In this case, from a Knative perspective, there's a lot of capabilities around revisioning services, routes, these sorts of things. So let's go ahead and implement a function, in this case, stock report revision A. All right, once again, revision A composed of the normal built-in primitives. So, we're not requesting containers, we're requesting functions, and we use the system, the declarative control, in order to handle the creation of these low-lying primitives. Next thing that we want to do is maybe a cron job for running our functions. Maybe this is a function that needs to kick off on a schedule versus being invoked dynamically. We can do that too. We now have the understanding of the metadata around running these, and Kubernetes now knows how to handle a Knative cron job. So once again, that's scheduled and running. Then, as I alluded to earlier, we need to be able to do revision control. So if we want to roll out a new version of stock report, revision B, we're going to need to be able to work with Kubernetes to tell it, how do we want to steer the traffic? Because, we're pretty sure revision B works, but we're not 100%. So let's take a soft approach and just roll some of our traffic over there. And so we go through and via the API, send the request in. And once again, Kubernetes via the Knative controllers rolls out revision B and then has the services via Istio, or you don't have to use Istio with Knative, you can use other things. But essentially having the traffic management being split across the different functions. Another one is machine learning as a service. Tons of open source projects out there. This one just using Kubeflow as an example, but in sort of the data science land from a machine learning perspective, there's a large number of components that need to come together to formulate a whole platform. You need to prep the data, train your models, package your models, validate the models, deploy the models, monitor the models. And for all these different kind of stages within the pipeline, there's tons of tooling that needs to be invoked in order to accomplish these things. And so it does make sense to use Kubernetes, extend it in order to use that declarative model to handle a lot of these things so that people don't have to do a lot of manual interactions to get the capabilities that they're using. And so as I expand this out, you're going to see a lot of the common threads from each one of these examples coming through. Tenancy, repeatability, integration, data management, and UX, and then for machine learning, in this case, GPU support and being able to schedule for that. And so if we take Kubeflow, we have very similar models. We have the Kube API. We can define a lot of those components so that when we send those requests in, we can use the custom controllers to handle these. And we can then expose Kubeflow to the users so that they can bring in their workbooks or whatever projects that they want to, use something like DEX for authorization authentication using OIDC, and be able to have their own machine learning spaces in order to work through and have that namespace so that other people's projects aren't cluttering up their views and these sorts of things. And so once again, from a generalized perspective, here we are using Kubernetes to create a platform, which isn't all about just creating containers in the environment. And, actually, this is an old screenshot. This landscape is a lot more complicated these days, if it wasn't complicated enough. But, when I say complicated, the reality is it just means there's a lot of choice out there in terms of what you want to do and how you want to do it. And so in the very beginning, I mentioned, there's a lot of these common threads and capabilities that you need to instantiate for creating a platform. But they don't necessarily create business value for you. So just grab these tools, integrate them, and then focus on how you provide, those unique capabilities to your business that makes your platform sticky to the business and won't easily be disrupted by, let's say, shadow IT and outside services and these sorts of things. So kind of where am I going with all this? So in my mind, I normally kind of see things as a kind of a maturity step where I look at things from a journey perspective. And so what I have, typically the view that I see is like going from, here we are, physical machines and VMs. Okay, VMs, there's a lot of them. We're going to need to wrap that up with some sort of service model. Okay, we now have IT understanding what a service model is. We have infrastructure as a service. What is the next evolutionary step from there? Maybe perhaps if you're an organization that does a lot of application development, you can create a platform to facilitate that easily so that you don't have, let's say, 10 different application teams with 10 different CI/CD stacks and 10 different ways for handling the same compliance and regulatory or security testing controls that they need to do. Might as well centralize that on a platform and allow them to quickly utilize and access those capabilities without having to spin up their own. The next would be an API platform. An API platform allows you to come up with different sort of business models in order to interact with other groups, whether that's internal organizations or internal parts of your organization to interact with one another, when historically it may have been person-to-person communication to do those interactions, or sort of some sort of business-to-business or business-to-consumer model where you're providing these API platform capabilities. And ultimately, kind of where this is trending to is a business platform. And I would say a organization is a platform organization when, let's say 50% or more of their business is coming through that platform. Now, I have these things listed here sequentially, but that doesn't mean that every organization has to go through these steps. It's just a way of kind of listing these things in a way that makes sense in terms of progressions up the stack of capabilities. So, for instance, Segment IO, they obviously didn't start out infrastructure as a service. They're an API platforms business. same with Stripe, etc. So you don't have to start in one particular way and work your way to the other. Sort of why are these important? Yeah, I think probably many people in this group have seen for themselves that the historical model of going through from an IT perspective and defining a capability for the business and sort of locking them into that silo, saying, mandating, you have to use this system as the approved system, and you can use no other. Things have changed quite a bit. Shadow IT has definitely made a massive influence into this model. And so really the effective organizations are taking, what I would call like the mashup approach. And this is where you define things that are going to improve the life of your user. And hopefully, if they see that value, they're going to use it. And if they don't, they're going to use something else, right? So we are defining capabilities in a competitive scenario. And this is why it's super important, as I mentioned, understanding who's the provider, who is the consumer, and what does that UX look like. So to kind of give some examples, for instance, Expedia, we all know, we probably either have used them or we're pretty familiar with the model by now, going on their website and ordering your plane tickets, your hotel tickets, your car rental, etc. And, I'm sure most people would probably assume, that's where the majority of the revenue comes through. Not quite correct. The 90% of their revenue comes through their APIs. So what this means is that they have an API platform that they make available to other businesses so that the businesses can effectively create their own businesses in order to interact with that API model. And so like I said, the majority of the revenue is actually coming through their API systems, coming through that platform versus their website that's made available. Valve is a gaming company. For those who play video games and things like that, will be super familiar with Valve and their games called Half-Life, etc. Some time back, Valve decided to create an online store called Steam, which they can sell their products through. And that became wildly successful. And so I think it's, if not still, the biggest store for people to purchase video games, not just from Valve, but from pretty much any software vendor. And it's become so successful that Valve no longer has to create video games. So it's a gaming company that doesn't even need to make any games to be highly profitable, just based upon a successful platform alone. People who are waiting for Half-Life 3 are probably crying about that. Another example is Twitch. So this is an online streaming service, also sort of in the gaming territory, but people also use it to stream. For instance, like I used to use it for streaming programming sessions so that people could see how I programmed Kubernetes components and things like that. But you can use it to stream anything, really. And so the interesting thing here, what Twitch did from a platform's perspective is they created an API platform that anyone can use, whether you're a Twitch streamer, somebody who's viewing streams, or in this case, more importantly for our conversation here, a game developer. You can use their API so that, for instance, if somebody's watching a streamer who's playing a game that you've developed, you can offer capabilities to those users in the game based upon their attendance to the streams. So why is this important? If people are watching the streamers play the games, they're going to see the game more and are more likely going to play the game. So if you offer them like what's common is like loot drops or in-game items based upon them watching streamers, you've kind of got like a circular sort of feedback loop or force loop, which allows you to drive a lot of adoption for your game. And so that was a pretty big change for Twitch, something that's been super successful and driving a lot of the AAA game companies to use their platform for game launches and all that sort of stuff. And so now, hopefully you can start to see, kind of where I've begun with a generalized platform capability to something that's more specific to the business, in fact, becoming the business. And so, if you recall at the very beginning, sort of the title that I had for this talk is Kubernetes, a platform for change. hopefully that starts to make a lot more sense now, because if you think about it, if you're developing a platform and you've got something that's super powerful like Kubernetes, which has a lot of extensibility sort of right out of the box, the sky is really the limit in terms of your impact on the business. And so with something like that, there's a few things that kind of come up from that in terms of like people, process, and culture, and not just technology. So, you can probably, it's safe to assume, based upon some of those things that I mentioned earlier, being able to create custom resource definitions, custom controllers, admission hooks, these sorts of things, that having a developer perspective on running a platform, creating a platform, is huge, right? So having the skill set to do the development, even from an operations perspective, is a massive game changer. And so the way that we organize teams from an IT perspective can start to look quite different in terms of, for instance, here, I'm using Joe Beda. So Joe Beda is one of the three people that started Kubernetes at Google, works for VMware now. And he has kind of a way that he looks at operations, where you have operators and developers, and these are groups of people. And on the left-hand side, you've got let's say different teams. So cluster services, you can consider this the people creating the platform, and then the application or application teams. These are the people who are consuming the platform. And because now, if you're bringing in development capabilities into the operations team, you effectively are another application team, right? So having operators and developers for cluster services, you can classify one group of people as cluster ops and other as cluster dev. Why the distinction? Cluster ops generally are more concerned either from keep the lights on perspective or development perspective with how the Kubernetes fleet is running and managed. Cluster devs are probably more focused on adding new features and capabilities, and they're not necessarily interacting with the users of the platform, where cluster ops probably are, either via some UX they defined, or maybe for some white glove services that they use to onboard new application teams. I'll list a few resources that I think are helpful for anyone who's kind of wanting to get further into this area and explore this area. Number one, Programming Kubernetes is an excellent book. This covers a lot of the areas that I mentioned at the beginning of the presentation around custom resource definitions, the admission chain, custom controllers, all that sort of stuff. So this would go through and teach you, from the very, first levels of understanding all the way through, how to do some quite effective work on Kubernetes. The next one that I would recommend from a book perspective is from Martin Kleppman, Designing Data-Intensive Applications. So this provides a really solid understanding of state persistence from a cloud-native perspective. And why I say this is important, because everything involves state of some kind. And the easiest way to blow up a platform or blow up a Kubernetes environment is have a misunderstanding of how the state looks in the system and managing it inappropriately. So I definitely recommend to pick up this book if you're using Kubernetes. And even if you're not providing, one of the examples that I had earlier, database as a service, right? Even if you're just doing Kubernetes as a service, I still highly recommend this book. And lastly, Clayton Christensen's book, The Innovator's Solution. Many of you will probably be familiar with his other book, The Innovator's Dilemma. But in here, I recommend this one specifically because he has a lot of great advice on how to work with consumers and how to think about UX and how to make sure that you're creating things that they're going to love and value. There's a tremendous amount of insight, and it is super important because if you're creating platforms, if you're creating services, you live and die by the UX that you define. As I mentioned, we now live in an IT world where we're developing things in a competitive atmosphere, whether it's another team within the organization that also want to build a similar platform, or it's some cloud provider or SaaS provider that's doing something similar, or if you're competing against the status quo, right? They already have a way to do something, even though it's not really efficient. A lot of people are not, too enthusiastic about change, right? Better the devil you know. So even if there isn't another team doing something, you're still competing against the status quo. And again, UX is king and is super important. So I highly recommend this book. And so that kind of brings us to the end of the presentation that I have for everyone. And so I just want to, again, thank you all and thank Pradeep and the team for setting up this meetup and inviting me to talk here. Thank you very much.
Thanks a lot, James. That was an amazing session, especially the analogy with pizza as a service. That's got a lot of gas running in my mind. Ravi had a question. Ravi, would you like to ask your question, please?
Yeah, so this is in regards to the KubeDB. So does KubeDB supports a specific set of databases, or I mean, if user requests any arbitrary database, something could be PostgreSQL or something like that? I mean, just to understand the length of support we get from the KubeDB.
Yeah, so support's an interesting term. KubeDB is an open source project. And so what you get is the capability to do something. Who supports it? If you're the provider of the platform, then you're the one that's doing support. So KubeDB has capabilities to handle certain databases, database management systems out of the box. Some of you may have seen in that slide. I definitely would, if you have an interest, to go to their website and see, the full picture of what they're doing. I did see in your question, something about arbitrary database. Is that like a question for like, can you extend KubeDB? Yeah. So not easily. And so I would say if you wanted to handle other database management systems, again, you could look for an existing open source project or something that provides that. Or if there's absolutely nothing, maybe you roll your own, maybe you open source that, something to that effect. So hopefully that answers your question.
Yeah, it does. Thank you, James.
Awesome. And then I saw another question about CRDs and how they relate to Kubernetes operators. So Kubernetes operators is a term that Red Hat made popular, but effectively is, you can just consider a combination of a CRD, a custom resource definition, and a custom controller to do something. So it's just a kind of cohesive term of two components within the Kubernetes system to accomplish something. So when somebody says operator, usually they're meaning bringing together a custom resource definition and a custom controller, if that makes sense.
Do we have any other questions for James? Okay, so thanks a lot, James. It was an amazing presentation. And thanks everyone else for your valuable time. I hope it was helpful. We would tentatively have another session of Cloud Native Brisbane in 4 weeks. Again, this is an open meetup group. We would love for others to participate. We've had some good representation from the BMA folks today. We would also like other organizations and even individuals to jump in and present their ideas and thoughts and help the community sort of grow and understand and help each other out. We tentatively have another session scheduled for 4 weeks from now on. But if somebody else has any other amazing idea that they would like to present, we would love to jump in and schedule another one much earlier if necessary. Again, thanks everyone for joining in, and see you all in 4 weeks then. Thanks everyone. Cheers.
Thank you.
Thanks, Pradeep.
Thanks. Bye.